This meeting is being recorded.
Good afternoon to all. First, I would like to thank Dr. Gingiri sir has given wonderful opportunity to me share our discussion with you previous year paid question paper 2020 in chemistry. So this is Dr. Vitthal Makane. I have completed MSc, NET, GRF, GATE, PhD. Now I am working as Assistant Professor, Department of Chemistry, CB Khedgi, Bachelor Science, Raja Vijayashree Commerce and Raja Vijayashree Art College, Akkalkot. Now today we are discussing the previous year question paper, PATE 2022 Chemistry. See here in the first slides, here total number of 15 questions are there and time duration is 16 minutes. Means this 50 question we have to solve in 16 minutes. Now we'll not waste your time. We'll discuss the first question. See the question number 1. Myoglobin and oxymyoglobin respectively are diamagnetic and diamagnetic. B is the paramagnetic and paramagnetic. C is the diamagnetic and paramagnetic. D is the paramagnetic and diamagnetic. So here answer is, we'll see the answer is D. Now in the question first, myoglobin and oxymyoglobin respectively are known as. Here in myoglobin, 4 unpaired electrons are there, and in oxymyoglobin there is a no unpaired electron. If the unpaired electrons are there, so that compound is a paramagnetic. Yes. And if paired electrons are there, so that compound is a diamagnetic. In question number first, answer is the D. Why? Myoglobin contain 4 unpaired electrons and oxymyoglobin contain no unpaired electrons. If unpaired electron is there, so that is a paramagnetic. If there is a no unpaired electron, that is a diamagnetic. Now let's discuss the question second. What is the incorrect for borazine? See here, option number A, borazine is a isoelectronic with benzene. Option number B, borazine has similar physical and chemical properties as a benzene. Option number C, borazine is a isostructural with benzene. Option number D, borazine has electron-rich nitrogen and electrophilic boron atom in the ring structure. So here option number B is correct. Why B is correct? You can see this is the borazine. So borazine it is called we can call as a inorganic benzene. So borazine is isostructurally with the benzene. But in option number B, see, borazine has similar physical and chemical property as a benzene. So what is our question? What is incorrect for the borazine? So option number B. Why B? Because borazine and benzene total physical and chemical properties are the different. Now see the question number third. Which one of the following statement is not correct? Yes. So carbon 10 is unstable because it has too few neutrons. B, all nuclides with Z greater than 83 decay into nuclides with smaller Z value. C is the generally the number of neutron in a nuclides is equal to or less than the atomic number. And D, as the atomic number increases, the ratio of neutron to proton in a nuclide increases. So in this question, incorrect sentence you have to find out. So C number is the correct. Why C number is the correct? See, in the C number, nuclides. See, generally the number of neutron in a nuclide is equal to or greater than the atomic number. We cannot write the less than the atomic numbers. Question number 4. In the electron paramagnetic resonance trigonal copper complex, where G parallel greater than G perpendicular greater than G in excited state. Unpaired electron residue in the orbitals. See here in this question, just write the electron configurations of copper second complex, and in the second complex write the electrons. See, in the copper second complex, in the d orbital 9 electrons are there. But you can go to the concept. Here answer is C, but here answer is given B. B also correct, because in this question John Taylor effect is there, and this question is very very important. Just you can see the previous year question paper, net, set, get, everywhere this question is there, because here is a John Taylor effect is there. So answer number B is the correct. Dx square minus yz. A, B, C, D. These are the orbitals of the d orbitals. So I will not read all the options. Yes, question number 5. Among the following, the strongest oxidizing agent. So which is strongest? Here is tungsten, rhenium, chromium, and manganese complex are there. But you can see in the periodic table, rhenium is the highest oxidation state. The oxidation state of rhenium is a +8. So you can see the tungsten, chromium, and manganese it having the very low or less than 8. So option number B is the correct. Question number 6. Which halogen nucleophiles is weakest in the polar aprotic solvent? Which halogen nucleophile is weakest in the polar aprotic solvent? I minus, F minus, Cl minus, another is a Br minus. You can see the nucleophilicity order. So in the nucleophilicity order, top to bottom is a decreases. So iodine is the I minus is the correct answer. Yes. Question number 7. The molecules diaboranes belongs to the symmetry point groups A, C2, B, C2H, C, D2D, and D is the D2H. So in this question, we have to write the symmetry element. So symmetry elements are C2X, C2Y, C2Z, EI, sigma XY, sigma XZ, and YZ. So for this symmetry element, D2 is the point group. So here answer D is the correct. Yes. Question number 8. The reaction given below is the example of E2 elimination, E1 elimination, Cn elimination, and E1Cb elimination. So here, as you know, you can see this structure. In this structure, here nitro groups. Yes. So alpha protons are there. With respect to this electron withdrawing groups, so these alpha protons are the highly acidic. So base will abstract this proton. This proton since comes in the conjugation, means here we can write the E1Cb elimination. So E1Cb elimination is the option correct, because in E2 elimination, that is one step. E1 elimination is the two step, and there is a no Cn elimination. Yes. Question number 9. The cluster types of Fe5 cobalt 14 nitrogen and cobalt 6 cobalt 13 nitrogens are respectively. Yes, here A, B, C, D options are there. First A option nido nido, B is the nido closo, C is the closo nido, and D is the closo closo. So here you have to go through the boron chemistry. We have to see the formulas for closo BnHn minus 2, nido BnHn plus 2, arachno BnHn plus 6. And here is a complex molecule is there. So in the complex molecule means total number of metal you have to count. On this, by using this formula, we can calculate. Yes. So here in these two complexes, yes. So these two complexes, answer is the B, nido closo. First complex is nido, second complex is closo. Yes. Question number 10. Consider the ions here: europium, gadolinium, samarium, and lutetium. The observer and calculator the magnetic moment value are closest for the pair of electron. So here we have to calculate the magnetic moment. Magnetic moment. So how to calculate the magnetic moment? We have the formula mu is equal to square root n bracket n plus 2. N is the unpaired electron. We have to find out the unpaired electron. But here gadolinium and lutetium, these two elements having the very close magnetic moment, means observe and calculated. You can see the gadolinium is 7.9 and lutetium is a 7.8. So option number A is the correct. Question number 11. Which of the following is a benzoate is a aromatic compound? See here, this is very good question. Because why I'm saying the good question, you can see here, this question also asked in the previous set exam. See, benzoate aromatic compounds means simple. The aromatic it contain benzene ring is must. Option number A is azolene, B is tropine, C is tropolene, tropolones, and D is phenanthrene. You can see here D number is the correct answer. Why? Because phenanthrene contain benzene rings are there. Azolene, tropolene, tropolone does not contain the benzene rings. Yes. Question number 12. The cyclic product of the following photochemical reaction is, you can see the structure, and this structure, this compound we are treating with H-mu, sorry, H-mu vapor phase. So here first option is only cis 1,2-dimethyl cyclopentanone, B option is a only trans 1,2-dimethyl pentane, and C is the mixture of cis and trans 1,2-dimethyl cyclopentane. D is the only 2,6-dimethyl cyclohexanol. So here answer is C. Why answer is C? You can see the stereochemistry. Here we can get the racemic mixture. It may be cis or it may be trans, means 50-50%, 50% cis and 50% trans. Here stereochemistry cannot change. Yes. Question number 13. The point group obtained by adding the symmetry operation sigma h to the point C4 is. So here again you have to write the point group. A is S4, B is the C4H, C is the D2H, and D is the D4. So here option number is the D. Just now in the previous question number 7, I have discussed. Yes, again here you have to write the symmetry operation. On the basis of symmetry operation, we can write the point group. Yes, question number 14. The result of the product C2X, C2Y is, see, one molecule is there. In that molecules, one C2X axis there, C2Y is there. So another axis obviously is a C2Z. Yes, if the C2X and C2Y axis in a molecule, then there will be a C2Z axis as shown. So what is here? E, sigma xy, C2Z and I. C number is the correct answer. Question number 15, which describe the feed the following sugar based. Just see the structure. On the structure we can get the idea. First option is A is ketoses furanose alpha, B is the ketose furanose beta, C is the aldose pyranose beta, D is the aldose pyranose alpha. Here first you have to find out the structure. So this is structure of furanose, because in furanose contain, furanose is the 5-membered rings, but pyranose is the 6-membered ring. Means our option is A and B. So which one is option correct? A and B. See here, A and B. Here again, both are the similar. One is ketoses, furanose, but here alpha is there, and in B, beta is there. So how to find out alpha and beta? You can see the structure. In this structure, see in this structure, OH is the above the plane. OH is above and CS2OH is the below. We can call as a beta furanose. If CS2OH is above and OH is below, so we can call as a alpha furanose. So here you can write the stereochemistry on the basis of OH and CS2OH group. Now here answer is the B. ketoses furanose beta. Question number 16. In a compound N3P3F3, the geometry around the nitrogen and phosphorus respectively are A. Pyramidal and tetrahedral, B is a planar and tetrahedral, C is a pyramidal and planar, D is a planar and trigonal bipyramidal. So if you want to solve this question, we have to write the structure N3P3F6. Yes. So if you write the structure and you can see the hybridization of nitrogen and phosphorus. So here hybridization of nitrogen is sp2 and hybridization of phosphorus is a sp3. If sp2 hybridization means that structure is that nitrogen is a planar and another phosphorus is phosphorus having the sp3 hybridization. sp3 means tetrahedral. So option number B is the correct. Question number 17. In the H1 NMR spectrum recorded at 293 Kelvin, an organic compound C3H7N0 exhibited the signal at delta 7.8 1H singlet, 2.83H singlet, and 2.6 3H the compound is. See here, we have given the NMR data. On the basis of this NMR data, we have to find out the structure A, B, C, D. Here four structures are there. But you can see here 2.8, 2.6. Both are the singlet 3H protons are there. Now you have to look the first structure. In the first structure here one H is there and two methyls are there. Second structure, how many are there? Three methyls are there. But in a given data, there is no three methyls are there. Yes, means second option is not. Then come to the C. In the C, here two methyls are there, one proton is there. But whatever methyl attached to the nitrogen atom, that will come at a 3.1 delta ppm. Yes, but in that given data, there is no. And option number D, here methoxy is there. Methoxy will come at a 3.8. So you can see here in this problem, option number A is the correct answer. Why? Because 7.81H, yes, is for this proton, aldehyde protons. Yes. And here, this 2.8 and 2.6, 3H proton for this methyl groups. But this concept is depends upon temperature. Yes. If you take the low temperature, both the methyl groups, it comes at a 2.7 delta ppm. But here temperature is 293 Kelvin is there. So this is a higher temperature, means that methyl can rotate and it can change the delta ppm value. Yes. The major products formed when 3R4S 3,4 dimethyl hexa 1,5-diene is heated at 240 degrees Celsius is. So here you have to find out the answer. See in the all the option A, B, C, D. Octa 2,6 dienes are there. 2,6 dienes are there, 2,6 dienes are there, and 3,5 dienes are there. But you have to look the stereochemistry. In A, ZZ are there, 2Z, 6Z, B, 2Z, 2E, 6E, and C is 2E, 6Z, and D, 3Z, 5Z. As you know, EZ nomenclature systems, so E is the more stable than Z. Yes, so here this bond will isomerizes at 240 degrees Celsius. Option number B is the correct because here is a 2E and C 6E are there. Yes. Question number 19. A current of 12 ampere is passed through an electrolytic cell containing aqueous NiSO4 solution. Both the nickel and S2 gas are formed at a cathode. The current efficiency is a 60%. What is the mass of nickel deposited on cathode per hours? Now see here, this problem just now I solved, but I cannot write here. So here answer is the A. A answer is. 7.883 gram. Question number 20. The standard deviations for the speed sigma for Maxwell distribution test satisfies the relations. Sigma option A, sigma C is directly proportional to the temperature. B, sigma C directly proportional to the square root T, and C is the sigma C is inversely proportional to the temperature. D is sigma C inversely proportional to the square root T. So here option number B is the correct. Why? See here, sigma C is the concentration. It directly proportional to the square root of T. T is the temperature. Yes. Question number 21. In the mass spectrum of 1,2-dichloroethane, approximate ratio of peak at M by Z value 9800 102 will be. So here formula is there, and you know the chlorine abundant. So in the chlorine abundant, see here for chlorine, or as well as you can take the for bromine also. So what is formula? A is equal to 3, B is equal to 1. So A square plus 2AB plus B square. So by using this formula, we can calculate the M by Z peak. So here is option number B is the correct. So what is formula? Here I am talking. A is equal to 3, B is equal to 1. This you have to put in A square plus 2AB plus B square. So we can get 9 raised to 6 raised to 1. Yes. Question number 22. If psi is the wave function, the probability density function is given by mod psi square, mod psi cube, and mod tetra. So here, as you know, the probable density is the psi into psi star. Yes, but if the wave function is psi, so here option number B is the correct. Yes. Question number 23. If the concentration is C is increases to 4 times, it is the original value, change in the molar concentration for the strong electrolyte. See in the strong electrolyte. Option A 0, B is the B square root C is the 2B square root C, and D is the 4B square root C. See, strong electrolyte, if you increase the concentration, the ions also increases. Concentration, if you increase the concentration, ions also increases. And here what is in this questions here, B is the K constant. So if you in the electrolyte, in strong electrolyte, if you increase the concentration, ions also increases. So option number B is the correct. Yes. Question number 24. The most suitable reagent for the following transformation. See here, alpha, beta, unsaturated ketone compound is there. So option number A is the lithium aluminum hydride. B is the NS2 KOH, Wolff-Kishner reduction. C, NaBH4CCl3 means this is a Lucci reagent, or we can call as a Lucci reduction. D, lithium liquid ammonia, or here you can take sodium metal in liquid ammonia. So D is the Birch reduction. See option number first, if you use the lithium aluminum hydride, it can reduces this carbonyl carbon as well as this double bond. B, it can reduces only carbonyl, it cannot reduces this carbon-carbon double bond. C can reduces only carbonyl, it cannot reduces the double bond. So option number D is the correct. This is called as Birch reduction. In option D, lithium Li liquid ammonia treat with alpha beta unsaturated ketone. It can reduces only carbon-carbon double bond. It cannot reduces the carbonyl carbon. Yes. Question number 25. Which of the following is not suitable as a catalyst for hydroformylation? See here, this is question is very good. Why? Because here answer is here only. Hydroformylation. Hydroformylation. Yes, C double bond O. Yes, hydroformylation. You can see the option number A, B, C. Here all containing hydroformyl carbonyl groups are there. But option number D is the Wilkinson's catalyst. Yes. So this is not suitable for the hydroformylation. H2 rhodium PPS2 Cl. Yes. Question number 26. The two compounds below are. You have to see these two structure and we have to find out these two are the enantiomer. Option number A is enantiomer, B is the identical, C is the diastereomers, and D is the regioisomers. So as you know, in the enantiomer, so enantiomer means two compounds are exact mirror images of each other but not identical. Yes. So these two are the not enantiomers. See. Then come to the C. We'll see the diastereomer. We'll discuss the diastereomer definitions. What is diastereomers? Two or more chiral centers are not mirror images each other. That is called as diastereomers. See what I'm saying here? Chiral centers. And D is the regioisomers. What is in the regioisomers? Same molecules formula but different atom connectivity. So you can see the D, you can see the B answer. B is the identical. So these two structures are the identical. These two structures are not enantiomer, not diastereomer, and not regioisomers. So here just you have to see the definitions of enantiomer, diastereomer, and regiomer. So this structure two are the identicals. Yes. Question number 27. The absorption at lambda max 279 nanometer epsilon is equal to 15 in the UV spectrum of acetone is due to. Here you have to write the transitions. Pi to pi star transition, N to pi star transition, N to N star transitions, and pi to N star transition. You can look the acetones. Acetone having what is C double bond O is there, means N to pi star transition. So answer B is the correct. Question number 28. The IUPAC name of the following compound is given below. Here you have to find out the IUPAC name. Yes. So how will you solve this problem? See A, B, C, D. In A options, what is here? Z is there. So you can see the structure. There is a no Z olefin. Means first number option is not there. You can see B also 2s 3z is there. Again in the stereochemistry you can see here in the structure this is E. Our option number C and D is there. So in that you have to again find out. How we will find out? You can write the configuration of this oxygen atom. So you can see here you give the number first oxygen, then this CH2 double bond. Here you give second priority, CH3 is third, and fourth is the hydrogen. But here while writing this configuration RS, you have to write this bigger group. This is the long chain of aliphatic and this phenyl. You have to write at the left side. And this CS3 group you have to write right side and then you can write the configuration. So here answer is the D. Yes, question number 22. 1 mole of monoatomic ideal gas is transformed from 300 Kelvin and 2 atmospheric pressure to 600 Kelvin at 4 atmospheric pressure. The entropy change for the for this process is. See here various options are there. So here entropy change. So you have to go through the formula. This also I solved this problem, and here the answer is the A. 3 upon 2 R ln2. Yes. Again here, what is this question number 30? For the following complexes, the increasing the order of magnetic movement. So again here we have to calculate the magnetic moment. So here what is there? Titanium complex is there, chromium complex is there, manganese complex is there, and cobalt complex is there. So here already I discussed in the question number 10 how to calculate the magnetic moment. Mu is equal to square root n bracket n plus 2. So by using this formula we can calculate the magnetic moment. So here n is the unpaired electron. We have to find out the unpaired electron. Yes, on the basis of unpaired electron we can find out the magnetic moment. So what is your option? So see here various options are there, A, B, C, D. So here D option is correct. Yes. Question number 31. The least basic among the following is, see here aluminum tetrahydroxide is there. Then another is a lanthanum, cerium, and lutetium. Yes, these hydroxides are there. So you can see in the periodic table the basicity increases from top to bottom. But in our question is asked least basic, means less basics. So option number E is the correct. Aluminum. Aluminum will come at the top of the periodic table. Yes. Question number 32. In the following concern reaction, the product is formed by. You can see the structure. What is this structure? Is a cyclooctadiene, octatetraene. So you can see, but here different options are there, A, B, C, D. A option 6 pi electron disrotatory electrocyclization. B is a 4 pi disrotatory electrocyclization. C is the 6 pi quant rotatory electrocyclization. D is the 4 pi quant rotatory electrocyclization. Yes. So here this question you have to read from the pericyclic by Jagdamba Singh, and this question also very important. You can see the net gate set question paper. There will get this question so many times asked in the net also. So we have one tricks. For example, 4 pi electron photochemical, we can write the con, and thermal condition we can write the dis. For 6 pi electron photochemical, dis, and 6 pi electron for the thermal condition we can write the con rotation. But here you can see you can see the starting material and product. So in the starting material how many pi bonds are there? 4 pi bonds are there, and in the product only 3 pi bonds are there. Means only here 2 pi bonds are taking part in the reaction. So 2 pi bonds means here option is our 2 pi bonds means we can call as the 4 pi electron. Yes, 4 pi electron. So option number B and D is there. So in that again we have to find out. See here what I am discussing first. If 4 pi electron here, first you have to see the starting material and product. In the starting material only 2 pi bonds are taking part in the reactions. Means this is a 4 pi electron. Yes, 4 pi electron. So 4 pi electrons, and here condition is given thermal condition. Condition is given thermal condition. So thermal condition we can write the disrotatory electrocyclization. So option B is the correct. D option is the wrong. Why D option is wrong? See here 4 pi electron thermal condition we cannot write the quant rotatory electrocyclization. Yes. Question number 33. In a liquids of the density 1 gram centimeter climb to height of 0.5 centimeter when a capillary with the internal radius of 0.2 millimeter in a dipped it into it. The surface tensions of the liquid is the closest. See here, this is question from colloidal chemistry. So here option number A is the correct. This is a problem, we have to solve it. Yes. Question number 34. Which statements are the correct for the actinides? So what is question number 34? Which statements are correct for actinides? So here four are their statements. First statement, oxidation state are greater than plus 3 are more frequently in actinide than lanthanide. Option number 2, some actinide plus 3 ions show the DD transitions. Option number 3, here uranium oxides and polonium oxides are stable in plus 2 oxidation state. Option number 4 here, sorry, four sentence. Some of the actinides do not have radioactive isotope. What is the question? Which statements are correct for the actinide? So you can see here, we'll go from down. Fourth sentence. Some of the actinides do not have radioactive. You know, all the actinides are the radioactive. Means this sentence is the wrong. Then come to the third sentence. What is your uranium plus 2, uranium oxides and polonium oxides are stable? Yes, that is correct. Third one. Then come to the second. Some actinide plus 3 ions show the DD transition. That is also wrong because in the antinide, here lanthanide, actinides, this is from a block element. So there DD transition will not occurs. Means that sentence also wrong. Come to the first, oxidation state are greater than plus 3 are more frequent in a actinides than lanthanide. So that sentence also correct. You can see your options. Various options are there: A, B, C, D. So option number A is the correct because A contains first sentence and third. Yes. Question number 35. The Gauche interactions value for methyl bromides and bromides are 3, 0.8 and 0 kg per mole respectively among the following most stable conformations of 2,3 dibromobutane. See here, these all are the structure of butane Gauche interactions. So sorry, these all are the structures are the Gauche interactions. You can see here first A, B, C, D. If you look this structure, so might be you know, so B option is correct, but here B is not correct. Here option number D is correct. I will explain you because see here, mm, see why I'm saying the B is correct. See here, these methyls are anti. Yes, means there is a no steric repulsion as well as there is a no dipole moment. This bromine also not close. Come to the A here, bromines are very close. This CS3 also close. Means there is a steric repulsion is there as well as dipole interaction is there. Come to the B, there is a no steric repulsion, there is a no dipole interaction. C, what is your again here same. What is your methyl means steric repulsion is there, dipole moment also is there in bromine. Yes, but come to the D. So D here CS3 methyls. What is here? There is a no steric repulsion. Yes, there is a no steric repulsion. So D option is correct. Why? As you know, if the here, if the methyls are very close, so 3.3 kilojoule mole. If methyl bromines are close, so we can write 0.8 kilojoules. And if bromines are close, so 3.0 Kelvin Kelvin joule per mole. But here we have given the energy. What is here? 3, 0.38 and 0 Kelvin joule. So what is this? See here, 3 means, see here, 3 means these bromines are closer. Yes, yes, from these two bromines are closer. So for two bromines are closer, 3.0 Kelvin joule per mole. Yes. Then another what is here? Another, this methyl and bromines are closer. So what is energy here? 0.8 Gauss, 0.8, but and 0. K 0. Sorry 0 kg mole. So here this is for this CS3 groups. So option number D is the correct. But if you see this stability order or stable structure, here stable structure is B. But we have to tell on the basis of this value 3, 0.8 and 0 kilojoule per mole. So that basis option number D is the correct. Yes, question number 36. Which of the following statement regarding the E1 mechanism is wrong? Here you have to find out the wrong statement in E1 mechanism. Read first question number, sorry, option A. Reaction by the E1 mechanisms are unimolecular in the rate determining step. B. Reaction by the E1 mechanisms are generally first order. C. Reaction by the E1 mechanism usually occur in a one step. D. Reaction by E1 mechanisms are multi-step reaction. If you see these four options, so in that look at the C options, reaction by the E1 mechanism usually occurs in a one step. So this sentence is the wrong. Why wrong? The reason is that, yeah, the reason is that even eliminations occurs in two step. First steps formations of carbocation, then proton is eliminated. Yes, but here in this option, the reaction by occurs even mechanism usually occurs in one step. So statement C is the wrong. Yes. Question number 37, the major product of the following reaction. You can see the structure. Here carbonyl is there. We are treating with the LDA at minus 78 degrees Celsius trimethylsilyl chloride and O3, sodium borohydride and hydrolysis. See here actually here 3-4 reactions are there. First LDA, LDA is the base. LDA will abstract the acidic proton from less hindered site. Yes, then this O minus will take part in the conjugation. Oxygen will get O minus. O minus will attack on silyl chloride. Silyl is eliminated. Then second step we have to do the ozonolysis reaction. Second step we have to do the ozonolysis reaction. So after the ozonolysis we can get the one side we can get the acids, another side is the formaldehyde. Then treat with the sodium borohydride. What is next? Reduction is there. Reduction is the sodium borohydride. So in the sodium borohydride, as you know, sodium borohydride can reduces only aldehyde. It is a weak reagent. As you know, the lithium aluminum hydride is the strongest reducing reagent. It can reduce aldehyde, ketone, acid, ester, amide. But here, sodium borohydride can reduces the aldehyde. So aldehyde is converted into alcohol, and that alcohol will attack on that acids. So you can see here the option D is the correct. But you have to go through the mechanism, otherwise you cannot get, because here mechanism is very, very important. Yes, now we can see this carbon structure. Both the sides are the alpha protons are there. One side methyl group is there. Another side there is no methyl group is there. But we are using the LDA. So LDA is the bulkier base. So this bulkier base can abstract from less substituted side proton that take part in the conjugation. O minus will come. O minus will attack on silyl chloride. Cl is eliminated. Then here double carbon carbon double bond will get. So that carbon carbon double bond treat with O3. This is simple ozone lysis reaction. What will happen? That bond will break. One is converted into aldehyde. Another is the acids. Then treat with the sodium borohydride. Sodium borohydride can reduce the aldehyde. Aldehyde get converted into alcohol. Alcohol will attack on acids. Yes. So option number D is the correct. Here I explain the repeat because in organic chemistry without mechanism we cannot write the product. Mechanism is very, very important. Yes. Question number 38. The first person to separate a racemic mixture into individual enantiomer is. So what is the meaning of racemic mixture? Means in that structure R and S is there 50-50%. So who separated? Here different scientists are there. E is a J.H. Wandhoff, B is a Poscher, C is a H.V. Fishers, and D is the Holler. So option number B is the correct. Yes. Question number 39. A crystal has the lattice parameter A is not equal to B, B is not equal to C, and alpha is equal to beta, beta is equal to gamma is equal to 19. The crystal system is trigonal. A, B is a monoclinic, C is a cubic, and D is a orthorhombic. So here option number D is there. This is question from 12th book. Just you have to see the NCERT book. There 7 crystals are there. 7 crystals having 7 different angles are there. Sorry, 7 different lattice parameters are there. So option number D is the correct. Yes. Question number 14. The number of nodes present in the highest occupied molecular orbitals of 135 hexatriene is it ground state is. So here first you have to write the structure of 135 hexatrienes. Then you write the what is question here highest occupied molecular orbital. Here we have to find out the nodes. So how many here pi bonds are there? 3 pi bonds are there. Means you can write the 6 uh, we can write the 6 orbitals. Yeah. So first you can see here psi 1, psi 2, psi 3. Then psi 4, psi 5 and psi 6 that are in the uh, in star cases. Yes, means we can call as a psi star 4, psi star 5, psi star 6. So in our question, highest, here we have to find out the highest occupied molecular orbitals. We have to find out the nodes. So first node is a 0, then 1, then 2. 2 is the highest occupied molecular orbital nodes are there in 135 hexatriene. So for this question, I would like to suggest please read the Jagdamba Singhs. In Jagdamba Singh, very nicely explained by Jagdamba nodes concept. Yes. Question number 41. Let psi NLM denote the eigenfunctions of Hamiltonian for the spherically symmetrical potential VR. The wavelength psi is equal to 1 upon 4 psi to 10 plus square root 5 psi to 1 minus 1 plus square root 10 psi 2 to 1 is an eigenfunction only of. So here option A, B, C, D. So here this is question 41. So here see L, what is L? L is the orbital angular momentum. Z is a direction and H is a Hamiltonian. So option number D is the correct 2L and LZ. Yes. Question number 42. In case the phase diagram of water, the solid liquid boundary has a negative slope. The reason for the unusual behavior can be traced to decrease in A. Density of the system on melting, B. Volume of the system on melting, C is the entropy of the system on melting, D is the enthalpy of the system on melting. See here option number A and B is there. See what will happen. So in the question has a negative slope is there. Solid liquid boundary has a negative slope. What is mean by negative slope? It indicates that increase the pressure on the surface. Ice causes it melt to the or it melt to the liquid. So what will happen here? So here, see here I am getting the confusion. Option number A and B. Maybe it effect on volume of the system on the melting. So my opinion, option number B is the correct. But what happened here? Question number 42 and question number 43. Both the questions are similar. I think here is a mistake. So in these two questions, one question option number B is given, and another question means in 43 option is the A is given. So you can see here both the answers are more or less is correct, but you can see the accuracy. B is, my opinion, B is the correct. You can see here B is a 75% and E is a 25%. Yes, question number 44. Which one of the following is a cis-terpene? So here just you have to write this structure. You should know the structure A, B, C, D. Limonene, rubber, gingiberine, and squalene. You can see the structure. On the basis of structure, we can get this problem. So what is here? Gingiberine contain one monomers of the cis-terpene. So option C is the correct. In the nuclear fission produces the energy because A, neutrons are produced, B, the total mass of the product is less than that of the reactant, C, total mass of the product is more than that of the reactant, and D, it is a very powerful chemical reaction. First here, this is a nuclear fission, this is not fusion. So fission means, so option number B is the correct. Why? See here, the total mass of the product is less than that of the reactant. So that time it can produce the energy. Here again question number 46. Number of microstate present in a 3 of terms is. Option A is 3, B is 21, C is 19, D is 28. So option number B is the correct, 21. So here you have to calculate the microstate. We have the formula calculation of microstate. So 3F, 3 is the multiplicity. So what is formula? In bracket 2s plus 1, another bracket close, another bracket 2l plus 1. L is the multiplicity. So for here, S is 0 value, P for 1 value, D for 2 value, and F for 3 value. So already in this question, we have given the multiplicity. So by using this formula, you can calculate here. So we can get the 21 microstate for the 3F. So here question number 47. The correct order of nephrologic parameter of the ligand is. First, you should know the nephrologic effect and parameters. So both are the different. You can see here nephrologic effect is what is nephrologic effect? Less inter-electron repulsion. In a molecules, any molecules or compound, if the less inter-electronic repulsions, so their nephrologic effect is more. And in nephrologic parameters, more the electron repulsions, so more nephrologic parameters. So you can see here nephrologic effect is inversely proportional to the parameters. So here you can see the various options are there. I will not read these options. So option number B is the correct. Yes. What is this question number 48? In the IR spectrum of para-nitrophenyl acetate, the carbonyl absorption band appears at. So here you have to keep in mind the IR frequency of aldehyde, ketone, acid, ester, amides. Here is a para-nitrophenyl acetate is there. You have to write the structure of para-nitrophenyl acetate, and here the you can see here different frequencies are there. But in para-nitrophenyl acetate, para-nitro is the electron withdrawing groups, so it can abstract, it can withdraw the electron from carbonyl carbon. So if you draw means the carbonyl carbon, it can get the very less electron density. If the less electron density means carbonyl frequency is the increases. So here you can see here carbonyl frequency. So option number D is the correct. So here I would like to suggest you have to keep in mind the IR's value of aldehyde, carbonyl carbon aldehydes, ketone, acid, esters and amides. Yes. So here actually in the structure para-nitrophenyl acetate it is look like the esters, but that phenyl rings having the para position nitro group is there. So that nitro group can abstract the protons. Yes. Or it is electron withdrawing group. It can abstract the protons. So it can decreases the carbonyl carbon density. If the decreases the carbonyl carbon density means IR frequency will increases. And yes, so here option number, sorry, yeah, option number C is the correct. Sorry, option number D is the correct. 1716. Yes. Question number 48. Among F minus, Na plus, O2 minus, and magnesium plus 2 ions, those having the highest and the lowest ionic radii respectively. See here, what is question here? Here you have to find out the highest, sorry, first, yeah, having the highest and lowest ionic radii. So you can see here which one is the highest ionic radii. O2 minus. Yes. And lowest magnesium plus 2. Just you have to see here option A, B, C, D. So in A, here A, B, C, D. You can see here in the C, O2 minus is there and magnesium plus 2 is there. So option number C is the correct, which having the highest and lowest ionic radii respectively. So question number 50, which statement is incorrect? A option, at a constant pressure, delta H is equal to delta E plus delta U Pu. B, the thermodynamic symbol for entropy is S. C, gives free energy is a state functions. And D, for an endothermic process, delta H is the negative. So what is our question? Incorrect sentence. You can see here incorrect sentence. Just you have to look at the option D. So as you know the concept exothermic reactions, in exothermic reactions, a reaction release energy from the system in the form of heat. Yes. So delta H is the negative. But here in the option given endothermic process. So in the endothermic process, see in the endothermic process, the reaction that absorb the energy from its surrounding in the form of heat. So here endothermic delta H is the positive, but in option given negative. So D answer is the correct.